you have n bags numbered from 0 to n minus 1. We are given two zero-indexed integer array capacity and rocks. So the ith bag can hold a maximum of capacity rocks, and currently contains rocks. So we are required to return the maximum number of bags that could have full capacity after placing the additional rocks in the bags. So for this problem, the direct method for our first sort is a greedy method. So we could write here a greedy method. The first step, basically, we can compute the remaining capacities in each of the bags. So with the additional rocks, we need to first fill the smaller remaining capacities. So this is the greedy step. So there are also the possibility that there are some bags, the remaining capacity is 0. In other words, we do not need to put additional rocks in order that the bags are full. So let me write down the solution here. So the step one is to compute the remaining capacity in or remaining room to fill the bag to full capacity. Then for a preparation, we need to sort. We need to do a sort. So the sort from smaller to larger. Then we compute the number of bags that can be placed full using the extra stones or rocks. So here for the sort step, so actually we can use from the requirement of this problem. So we can direct sort. Sort is basically an n log n algorithm, or we can use this heap, so to pop and then fill. So now let's write the code. First step, let's compute the remaining capacity. So here for the ease, we can compute the remaining capacity in place in capacity. So let's first introduce a variable which is the length of capacity. In other words, the number of bags we have. So then for each of the bags, we compute the remaining room for to get full capacity. So here is a simple for loop for I in range m. So we capacity I, so we minus or decrement each of the capacity by the rocks it already have. So this way, the result will be the remaining rooms in order to fill them. Because we are using greedy method, so let's first sort this one. So we can sort in place. So the default behavior of sort is to sorting the resultant capacity in the increasing order. So now we would like to fill the bags. So after we do the sort, so there's basically two ways. So we can use a while loop or we can use a for loop. So let me first use a for loop here. So we for I in range, so m. So we want to scan the current state of capacity from left to right. So if the capacity capacity I is 0, we just continue. If it's not 0, so we need to update the remaining rocks. So so there's two possibilities. First is if capacity I is less than is greater than extra. So in this way, in other words, for the index I bags, we cannot make it to the full capacity. Therefore, we need to we just need to return I. So here I means that we have been able to make the bags from index 0 to index I minus 1 to be full capacity. That is, we have n bags in full capacity. So otherwise, so if the capacity I is less or equal than extra, which means that we have enough rocks to fill this bags, so we just need to update the extra by minus this capacity I. Right. So if after this whole loop for loop, we still do not return anything, so it means that all the bags can be filled to full capacity. So in this case, we return n. So so basically, there's a thought involved in this algorithm. So here for this thought, so the time complexity is basically n log n. So otherwise, all the parts for this this one is linear. So overall, the time complexity of this solution is n log n. So let's test the solution. So you can see it passed this one, and then we submit. So yeah, so we get the result. So here, as we mentioned, so as some details. So here we can use a for loop. Actually, we can also use a while loop to make it well controlled. So let's replace this one by a while loop. So here for the while loop, we can set a initial variable with I. Then the condition is that we check if I is less than n or x, and at the same time extra should be greater or equal than 0. If this is the case, so now we check the capacity I. So if it's 0, so it means this bag at index I is already in full capacity. So we just increment I by 1. So otherwise, we need to use some extra rocks to fill these bags. So there are two cases. First is the capacity I is less or equal than extra. So in this case, we can update extra by decrementing it by capacity I. So this case, we can increment this by I plus 1. Otherwise, so capacity I is greater than extra. So it means up to this stage I, we cannot fill this index. So we do not we just return I. So here I means the bags from 0, 1 up to I minus 1, because index I bag cannot be fulfilled. So yeah, so basically so if the final result, we want to return the final state of I. So let's run this. Okay, so yeah, that's basically the solution for this problem. So overall, the solution to this problem is an easy problem. The method we use actually is a greedy method. So if you like, you can also use a min heap to pop each time to compare with the extra, and then to check how many bags you can fill. In other words, we mimic the process of filling each of the bags into its full complexity. Thank you.